All right, well, hello everyone. My name is Bhautik Joshi, and welcome to Introduction to 3D Printing. So we're going to run this over the next 5 weeks or so, and we're going to be going into sort of the basics for 3D printing. We're going to look at, how is it that you think about a particular thing that you want to make and actually make it real using 3D printing. We're going to go into sort of like a lot of sort of the tips and tricks and really sort of the craft of 3D printing, because a lot of this you won't find online in tutorials. It's one of those things you really have to sort of have somebody else show you, or you sort of get into it a little bit yourself and actually try it out. And we're going to show you the kinds of things that 3D printing can do and what it can't do, and how to find sort of the right balance between the two. So first of all, just a little bit about me. So I am a sorry about the accent. It's a little bit confused. I live somewhere between sort of British, Australian, and American. I've sort of lived roughly about a third of my life in each one of these places. So my apologies if it sort of swings around a little bit, and let me know if I'm not being comprehensible and I can try to slow down. So my apologies in advance there. I got my start actually. Well, I guess notably, let's talk about sort of the last third of my life. I've been in the US, and I started out here at Industrial Light and Magic. So I was a research engineer over at Lucasfilm / ILM, and I had a great fun over there, basically messing around with movies. It was a good time, building a lot of sort of like tools for artists and helping them sort of basically build them, giving them bits and pieces so they can generate imagery to put on the screen. That was a ton of fun. And then after that, I really sort of like indulged my photography a hobby, and I was another researcher. I was over at Flickr, and Flickr is this big photo sharing website, and my job over there was to sort of like working with artists and trying to find ways of surfacing really interesting artists based on sort of like literally the millions of images that came through every day, and that was a good time. And my current job right now is I'm a sort of a senior researcher dork over at Adobe, and my job there is kind of a little bit all over the place as well, but I mostly work in the domain of immersive technology and image processing and capture. And I guess that's sort of like, this is where it dovetails with 3D printing, in that I need to build a lot of custom camera hardware. I need to build sort of a lot of custom rigs to sort of, glue bits of camera equipment together. And precision is important, alignment is important. So I ended up having to learn quite a lot about 3D printing in terms of making that possible. But then it also became a really interesting hobby for me as well, because there's something really special about designing something, but then actually holding it in your hands. I don't know how many of you folks are sort of like ever used to work at ILM in the model shop, or ever worked with sort of like making models or sculpting, but there's something really special about designing something, making something, and then holding it in your hands. There's something tangible about it that is sort of inescapably cool. And what I'm hoping to do is that I'm hoping to sort of like, for folks who don't have a 3D printer, I want to give you an idea of sort of like what that's like, and maybe sell you on it a little bit. So you might be inspired to sort of like go out and get one yourself and try it out. Alrighty. So first of all, just a little bit about me. So I am a sorry about the accent. It's a little bit confused. I live somewhere between sort of British, Australian, and American. I've sort of lived roughly about a third of my life in each one of these places. So my apologies if it sort of swings around a little bit, and let me know if I'm not being comprehensible and I can try to slow down. So my apologies in advance there. I got my start actually. Well, I guess notably, let's talk about sort of like, the last third of my life. I've been in the US, and I started out here at Industrial Light and Magic. So I was a research engineer over at Lucasfilm / ILM, and I had a great fun over there, basically messing around with movies. It was a good time, building a lot of sort of like tools for artists and helping them sort of basically build them, giving them bits and pieces so they can generate imagery to put on the screen. That was a ton of fun. And then after that, I really sort of like indulged my photography a hobby, and I was another researcher. I was over at Flickr, and Flickr is this big photo sharing website, and my job over there was to sort of like working with artists and trying to find ways of surfacing really interesting artists based on sort of like literally the millions of images that came through every day, and that was a good time. And my current job right now is I'm a sort of a senior researcher dork over at Adobe. And my job there is kind of a little bit all over the place as well, but I mostly work in the domain of immersive technology and image processing and capture. And I guess that's sort of like, this is where it dovetails with 3D printing, in that I need to build a lot of custom camera hardware. I need to build sort of a lot of custom rigs to sort of, glue bits of camera equipment together. And precision is important, alignment is important. So I ended up having to learn quite a lot about 3D printing in terms of making that possible. But then it also became a really interesting hobby for me as well, because there's something really special about designing something, but then actually holding it in your hands. I don't know how many of you folks are sort of like ever used to work at ILM in the model shop, or ever worked with sort of like making models or sculpting, but there's something really special about designing something, making something, and then holding it in your hands. There's something tangible about it that is sort of inescapably cool. And what I'm hoping to do is that I'm hoping to sort of like, for folks who don't have a 3D printer, I want to give you an idea of sort of like what that's like, and maybe sell you on it a little bit. So you might be inspired to sort of like go out and get one yourself and try it out. Alrighty. So what is actually 3D printing, right? So 3D printing is what's called additive manufacturing. And what happens is that, and this is sort of like a time lapse here of a 3D printer in action. And what'll happen is that you basically build your model up layer by layer by layer by layer by layer, right? And the formal term for it is, like I said, additive manufacturing. It really started off sort of like formally way back in 1981. This fellow by name Hideo Kodama, based in Japan, and he worked for a sort of an industrial research group over there. And he started working with this idea of photopolymers. And I'm not going to get too much into the details here, but this is sort of the modern, if you like, an antecedent of stereolithography or resin printers, which I'll get into in just a minute. But what happens is that you have some sort of like screen, and what it will do is that it will display an image on it, and where the image is bright, it will actually cause the layer of liquid on top of it to fuse into a solid shape, right? So that's what your that's what your resin printers do, right? So what they do is that the object will start printing by sort of like displaying an image for that particular layer, shining it until the polymer hardens, and then moving up slightly, and then repeating the process until the model is basically complete. In 1984, the formal sort of like accessible version of this, the stereolithographic process, was patented. And there's a lot of work in between that went on, but really what's sort of like where it comes back to sort of like modern day 3D printing was in 2008, this concept of a rep wrap started going around. And the concept of a rep wrap was that you can start making 3D printers that in theory could build all of the pieces that they need so that you can make another 3D printer, right? So this idea of a machine that could replicate itself. And of course, it couldn't do the assembly, but it was still a very, very, very cool idea. And I think that was one of the big sort of like, I guess, sources for where sort of 3D printing really took off from there. Okay, so in terms of like, where 3D printing is actually at, we have this concept of modern 3D printers, which will basically print by melting these spools of plastic and then putting down single layers at a time, right? And these are the most common types of 3D printers. So here's a sort of a time-lapse video of a particular sort of print that's going on. And you can see what's happening here is, again, this is sort of like sped up greatly. And what it's doing is that it's basically melting plastic out through a nozzle and using computer control to basically build it up a layer at a time. And what it will do is that over time, it will, typically either the head will move up or down, or the actual print bed will move up or down relative to the head. And, much like a sort of like I guess like an old school dot matrix printer works in terms of just like plunking down bits of material, it will basically just keep on putting down little blobs of material. So that's one particular type of class of 3D printer that is sort of easily accessible and very common. And the other type is a resin printer, right? So what the resin printer will do is that it will do the same thing as I mentioned in that stereolithographic process. So what you can do is that you get these printers that are effectively these vats of like photopolymer liquid that you pour your resin into, and it has like a little LCD screen at the bottom. And what it will do is that the head will start basically at the bottom. The LCD screen will expose the first layer, and then it will basically just goop upwards, printing a little layer at a time. And the resin printers don't have a moving head. They have like the entire layer is exposed all in one go, which means that you are, even though the prints are perhaps higher quality than you'd get out of an FDM printer, they are limited by the size of what your LCD screen is. And also the actual, the resin itself is quite toxic. And you need to have adequate ventilation, and you need to dispose of basically the used resin sort of fairly carefully, because it's a bit funky. So there's they're very, you have these basically two classes of options as far as types of printers that you can get. And a couple of classes in, I'm actually going to go into sort of like how would you make a choice between, say, buying a resin printer or buying an FDM printer. But just for now, I think it's just worth knowing that there are these two classes of approaches that are available. I wanted to sort of cover a couple of other types of 3D printers that are actually amazingly, surprisingly commercially available. One of them here is food printing. So legitimately, you can get printers now that sort of a food grade and food safe. And what they will do is that you basically that they may have one or more nozzles, and it allows you to literally print food. It's a hell of a thing. It's kind of cool, actually. And there's a couple of restaurants around the world where I guess they're all based around the theme of 3D printing food. So you have some sort of design, and it will print it out. And this is starting to become sort of like weirdly common. You can pick up I believe you can pick up a pancake printer, and what it will do is that it's effectively a heated bed, and where you basically make your pancake, and it will squeeze out the pancake batter in a computer-controlled pattern, and you can make it sort of fairly sophisticated. And those are not terribly expensive at all. I think they're on the order of something like a US $150. So this stuff has started. The actual 3D printing for food is actually starting to become sort of relatively accessible and relatively affordable. Another type of printing, well, why not 3D print a house? And it turns out this is totally possible. Instead of printing on a tiny scale, can you use it to actually put down layers for literally printing out a house? And these are used sometimes for remote construction in places where it's hard to move material in, but you can you can pour a whole bunch of concrete. And what they'll do is that they'll move the printer to where the house actually is. And that is just bonkers, right? So the idea is that you move your whole printer to the site, and then you have the printer, usually over the course of about a day, to actually print the house itself. And when you think about sort of like, you can build this to sort of whatever custom specification you like, and that you can actually do it in a day. I mean, really, when they say a house, we're talking about sort of like, a few rooms, maybe at most. It depends on the reach of the arm itself, and obviously you need to use a different technique to sort of put the roof on. But in certain types of scenarios, the idea of being able to 3D print a house is actually super, super, super useful and really cool. So those are a couple of different types of printers. So before we the next thing that I wanted to go on to was I wanted to sort of actually show you a 3D printer, and what I need to be able to do is I need to actually be able to kick off a 3D print. So what I'm going to do with you folks is I am actually going to get a print. I'm going to send it to my 3D printer, and then we're going to walk over and we're going to take a look at it and see what I can show you all the different pieces of how a 3D printer works, and specifically how it works when it's sort of alive and in motion. So I'm going to switch over to my desk view here, and I am going to bring up my 3D printing software. So this is the software that goes with my printer. And what I can do is, and I will go into sort of a little bit of specifics in terms of, what we're actually doing here soon. But what I've done is that I've taken a cube, and this is going to go down on the print bed itself. And I'm going to basically instruct the printer to start printing it, and we're going to see the layers being deposited down. So I am going to tell it to wake up right now. I've got this little camera inside my printer, and it just makes sure that there's nothing there, so I'm not going to print over the top of something that's already there. And I'm just going to go and hit print. So I'll go into sort of what it does in terms of slicing it and in terms of getting it ready for prints in just a minute. But let's go over and actually have a look at the printer itself. And this is a 3D printer. So let's go over the anatomy of this a little bit, right? So this kind of looks like a microwave, and this is sort of like, I guess what you call one of the, I guess, more higher end printers in that it's completely enclosed. Most 3D printers, they tend to sort of have, they tend to be open, right? So what you've got is that you've got a vertical arm that goes up and then the print head which sits on top of it, and that prints out on the print head itself. This one's a little bit different in that the print head actually moves and the bed moves up and down. But let's have a look at some of the actual pieces in here itself, right? So we've got the print head itself here, and what that does is that is going to move over the bed, and it's going to put down a layer of PLA, and it's just going to basically just keep on constructing those layers piece by piece by piece. And that print head is fed by the print spool. So this is where you can see I've got a spool of material here, which is this plastic PLA. The PLA gets fed into the machine. It gets heated up on the head itself, just here, and then the head will melt the plastic and start putting the layers down. Now this takes a little while to start printing because what it does is that it needs to get this up to temperature, right? So the temperature here on this one is about 200 degrees Celsius, and for the most common type of plastic, which is PLA, which is this, I guess if you like, biodegradable bioplastic, which is actually the most common and the easiest to get, the print temperatures are around sort of 195 to 200 degrees Celsius. And let's see if it is about to get going. So you can see here that it's going to, it's homing itself in terms of basically just locating where it's going to go. And let's see if we can wait just a minute for it to start printing. So just bear with me just here. I thought this was going to go a little bit more quickly, but that's all right. It's worth having a look at. There we go. So you can see here now that it's going to move over to the corner here, and I'm going to show you as it starts depositing material. So what it's doing now is that the print head itself is melting the material, and you can see here now that it's putting down this stringy bit of material here that is basically a leader out to the center of the print plate, where it's going to start basically drawing concentric circles, or concentric square pieces, I guess, for the base of the cube that we're going to print out, right? So you can see here, if we're looking just out from the side, for this particular printer here, the print bed moves backwards and forwards and up and down, and the head itself moves left and right. In other printer configurations, the bed itself is going to be completely still, but then the print head is the thing that is moving left and right and up and down. So I'm just going to leave this printer going, and what we'll do is that we'll come back to it in about 25 minutes, so we can have a look to see how it's gone. All right, so bear with me just here. I'm just going to walk you back. Okay, so the process, right? So let's talk a little bit about really sort of like what the three main components of 3D printing are, right? So, and they basically come down to modeling, slicing, and printing. So when we talk about modeling, we're talking about the, and for a lot of you folks who've sort of worked in visual effects or worked in 3D, this is very familiar. The process of modeling is literally creating your object, right? So, using whatever package you have, whether it's a 3D modeling package or something else, to go over your shape that you want to design and actually putting it into place and, generating the object that you want to be able to create. But then, the object then needs to turn into something that a 3D printer can actually create. And the way this is done is what's called slicing. So what happens is that the object is based on sort of like where the print, based on what orientation it's going to be sliced into lots of little pieces. And you can see what happens is that the model gets built up from the bottom. And sometimes your models, in fact, most of the time your models are going to have a hollow center. So you need to basically give the printer instructions in terms of how it's going to draw on that on those layers as it builds up, right? So a lot of what this is based on sort of precision. It's based on strength. These different types of patterns and different percentages of what's called infill will give you different model properties. But the slicing step itself it used to be a lot more complicated, but nowadays it's sort of fairly straightforward, and we'll talk about supports and rafts and what happens at the bottom of the model in a future class. But so I'll just leave that as sort of like abstracted away for now. But the important thing to remember is that when you're generating the model, it's generated from the base of the plate and then build up in layers on top of that. And then what happens is those slices, or the slicing, is turned into a series of control instructions for the printer. So what it will basically do is it will tell how the print head to move relative to the print base, and it will basically generate the model sort of layer by layer by layer. So here's the sort of a fairly standard example, and at this point you would have sort of been fairly familiar with this. So it'll turn that slicing directly into what's called G-code instructions. For most printers, it's called G-code, at least anyway. And those G-code instructions will basically tell the printer in terms of like what to physically do. And you can get pretty fancy with the G-code. So for example, you can tell the G-code to pause, so that you can insert, for example, like a metal component into your print. So if you wanted to embed metal in your print, for example, you can, as long as you're careful in terms of making sure that won't interfere with the print head itself, you can actually tell it to pause, so you can drop in a screw, for example. And then it will continue the print afterwards as well. So you can get extremely complicated with that, and it's a lot of fun. Okay, so those are the three sort of like, the three main parts of 3D printing. Okay, so the process, right? So let's talk a little bit about really sort of like what the three main components of 3D printing are, right? So, and they basically come down to modeling, slicing, and printing. So when we talk about modeling, we're talking about and for a lot of you folks who've sort of worked in visual effects or worked in 3D, this is very familiar. The process of modeling is literally creating your object, right? So using whatever package you have, whether it's a 3D modeling package or something else, to go over your shape that you want to design and actually putting it into place and, generating the object that you want to be able to create. But then, the object then needs to turn into something that a 3D printer can actually create. And the way this is done is what's called slicing. So what happens is that the object is based on sort of like where the print, based on what orientation it's going to be sliced into lots of little pieces. And you can see what happens is that the model gets built up from the bottom. And sometimes your models, in fact, most of the time, your models are going to have a hollow center. So you need to basically give the printer instructions in terms of how it's going to draw on that on those layers as it builds up, right? So a lot of what this is based on sort of precision. It's based on strength. These different types of patterns and different percentages of what's called infill will give you different model properties. But the slicing step itself it used to be a lot more complicated, but nowadays it's sort of fairly straightforward, and we'll talk about supports and rafts and what happens at the bottom of the model in a future class. But so I'll just leave that as sort of like abstracted away for now. But the important thing to remember is that when you're generating the model, it's generated from the base of the plate and then build up in layers on top of that. And then what happens is those slices, or the slicing, is turned into a series of control instructions for the printer. So what it will basically do is it will tell how the print head to move relative to the print base, and it will basically generate the model sort of layer by layer by layer. So here's the sort of a fairly standard example, and at this point you would have sort of been fairly familiar with this. So it'll turn that slicing directly into what's called G-code instructions. For most printers, it's called G-code, at least anyway. And those G-code instructions will basically tell the printer in terms of like what to physically do. And you can get pretty fancy with the G-code. So for example, you can tell the G-code to pause, so that you can insert, for example, like a metal component into your print. So if you wanted to embed metal in your print, for example, you can, as long as you're careful in terms of making sure that won't interfere with the print head itself, you can actually tell it to pause, so you can drop in a screw, for example. And then it will continue the print afterwards as well. So you can get extremely complicated with that, and it's a lot of fun. Okay, so those are the three sort of like, the three main parts of 3D printing. All right, cool. So what I'm going to do is I'm going to give us a little bit of a break and maybe take some questions if you have any. So let's go to a quick 5-minute break, and I'm going to make sure that you folks are unmuted. Do you folks have any questions so far?
For instance, the wrench that we saw, is it printed as several pieces separately and then assembled? Or
No, no, it's absolutely crazy, isn't it? Like it's printed in. There's this thing called printing in place. So what you can do is that you can um, what you can do is that you can generate, because these things are built layer by layer by layer. You can, I think the formal name for it is a captive mechanism, because it's built layer by layer by layer by layer. What you can do is that you can print something so that it is inside another object. And what will happen is that because you just gradually seal over the top of it, you can have this mechanism that is completely captive that lives inside. And you can build quite complicated things. So again, like, it's not super, super, super clear, but maybe I can show you. I've actually got a version of that with my leg mechanism here. So I'm just going to change it back to the overhead viewer here again. With my leg mechanism here, right here, these joints are printed completely in place, right? So you can see that I've got this axle here, and they connect over to this part of the leg. That is completely captive, so it's printed completely on the plate. So I don't snap these together, it's just there. And then when you get it off the print plate, you need to sort of like wiggle it a little bit, because you get these small strands of plastic that sometimes stick together a little, but they can be completely printed in place. It's absolutely bonkers. All right. We had a question from Simon. What about sending out for printing? Absolutely. There are lots and lots and lots of services, like, for example, like Shapeways. So if you don't have a printer at home and you're not sure about whether you want to commit to the time and expense of having a 3D printer, and they are kind of like having a pet, they do require a reasonable amount of maintenance. If you want to sort of get your feet wet but not have that outlay on getting a printer at home, you can send your prints to services like, I think, Shapeways. Shapeways is actually a fairly famous one. They've been going for a number of years, and Shapeways will actually do your print for you. They're quite something, and they will allow you. Notably, if you send your prints out to somebody else for printing, you get access to many more materials than you would than if you're printing at home. So, for example, and they can get gradually crazier, right? So you've got all the different grades of plastic that you can have for printing. And I think next week I'm going to be covering the different types of plastic that you can use. But then they can also do things where they can print it out of bamboo. So you can make it out of wood, or you can make it out of rubber, or even like, using very sophisticated printing techniques, they can do sintering. So they can make it out of aluminium if you really wanted to, right? So you can make these solid metal pieces that get printed. So there are absolutely options for sending it out for printing, and it does actually make sense to do that sometimes. Actually, it's sort of a reasonable segue into sort of one of my first 3D printing projects that I did. And we were basically, a friend of ours she's a poet, and she was going to be doing an art show, and she needed to make these hangers for her art, right? So the idea was that she was going to type up these poems, and she was going to frame them. And what happened was that, there was going to be the frame, and then, sorry, let's get this the right round. So there'd be a frame, and then the actual poetry would hang in the actual frame itself, right? So you've got this little thing which sticks on the wall, and then the bit of poetry would go inside. And this is when I was completely new to 3D printing, and I initially thought I could just print this whole thing all in one go, right? So I had this design. It was fairly quick. This was something we made in Tinkercad, so I'll show you that. I'll show you folks that a little bit later on. But I made this entire piece in Tinkercad, and I printed it out all in one go, right? So because I printed it all out in one go, each one of these pieces took about 10 hours to print. And because it took 10 hours to print, our volume wasn't high. And she said, okay, can I get 100 of these in 2 weeks? And it's like, no way, this is literally, there's no physical way that we could get these printed out. And when you first start out with 3D printing, you also have a fairly high failure rate. Again, something else I'm going to cover in terms of like, how often do these prints work? What kind of problems can happen? You can get issues with warping. So in the end, what we did was that we started with this design, but then we used it instead to prototype building it in pieces. So we changed the design so that it became this snap together design. So so we basically printed out each one of the parts of this basically as 3 layers, right? So we've got the front layer with the text here, and then we've got the middle layer, which is the base, and then we got the back, and they all sort of like snap or sort of glue together. And we then ended up taking that design and sending it off to actually a laser cutting service. So this is one of the cases where it made sense, because in terms of the question was like, can you send your stuff off to services? You can also you can also get services to sort of start combining your 3D prints with other materials. So we've got, for example, like these pieces that were actually laser cut. So and that's how we ended up being able to sort of do, I think it was like 150, and we were able to make them in a week by basically just printing them out as separate pieces. So let me see if I can grab this just here, but I'll show you what the laser sort of like cutouts look like. So what had happened was that we basically laid out the pieces that we wanted to print out on one of these sheets, and then you effectively just punch these out and then glue them together, and they're cut by lasers, and because they are laser cut, they're a little bit more precise than you'd get with a 3D printer. As you can see here, there's sort of fairly fine edges on this. But what you don't get is that you don't get the sort of like, the kind of nice rounding on the lettering that you get with 3D printing, right? So you can see here that we've got these nice sort of like rounded beveled edges on the letters. And we just, that would have been extremely difficult to achieve with sort of like any other technique. So in terms of like what you send out for printing, in terms of, I guess, like, choosing which tool you're going to be able to use to do all of this, that's really going to be variable depending on what you want to be able to do. Does that sort of make sense? Cool. Alrighty. Let's switch
I was wondering,
Yeah, please, go for it.
is the only way to know you messed up your design by printing it out and then figuring out, oops, that didn't work? Or do you have like simulation tools that can help you point out like, hey, you missed something there, or that's actually not going to move because it'll get stuck or whatever?
Yes to both. Yes to both. But I think in terms of, I think when you're starting out, learning from your mistakes, and again, I did mention like 3D printing is right now it's at a stage where it's kind of a bit crafty. There isn't really a lot that you can formally learn, because a lot of it involves like picking up a print and really seeing how it feels and going like, has this worked? Actually printing stuff out and failing often is really instructive, right? And I think it's a good thing to learn. But in terms of formally simulating the parts, unfortunately, for a beginner, it's inaccessible, right? You'd use like a proper CAD package like Fusion 360 to be able to design your piece and to actually then do a proper CAD simulation on the actual object itself and seeing, okay, right, is this going to work? How much does this piece rotate? What kind of friction is going on? What kind of tolerances are involved? All of that is relatively advanced. Unfortunately, right now it's not super accessible. Maybe that will change in the future, but right now it is, at least for hobbyists, it is somewhat intuition driven. So yeah. Well, that's it. I wouldn't worry about it. Like, and 3D printing is, after you've put the investment on the printer, relatively cheap, right? Like, if I look at this is probably about 2 cents worth of plastic, right? And however much power it takes to print, right? But it's it just takes time, and you just need patience to sort of go through it. But once you get into a good sort of rhythm for it, it's pretty quick. I mean, surprisingly, like this toy that I built, the transformer, the transforming Santa spider thing, that was a lot of fun. But surprisingly, it only took me an evening to put together, and a few days worth of just like iterating on the parts to print them, because I already had a library of pieces that I had in terms of connecting all the different parts of the transformer together, and especially the joints, because I had they're all using the same joints as I had when I had this transformer just here, if that sort of makes sense. So I basically just reused all those pieces, and it made it a lot quicker. So it gets faster as you go along, but initially it's kind of slow, but I guarantee it's worth it. I hope that answers the question. Cool.
Yes, it did. I was more worried about spending 10 hours waiting for something to happen and then being like, oh, whoops.
Well, okay. I mean that cube that I'm printing out right now. In fact, let's see how it's going. Right. Let me see if I can bring up a picture of it. Give me just a second. Let me turn on the web monitoring so you can take a look, and you can see that. Let me just. So what we do, there's a picture here of the printer, and you can see this this cube that I've printed out took about 25 minutes to make, right? So it wasn't incredibly complicated, but for making small objects, the amount of time that you have to wait varies, but it isn't very long, right? It's one of those. It's a nice hobby to have when you have got other things that are going on, right? So when you want to if right now, I mean, a lot of people are stuck at home. Nearly everyone is, right? So I do a lot of baking. So when I'm in between sort of like baking, this is the thing that I'll do. Like, I'll send a print off and off it goes. In fact, this is just finished. So you can see it's just lowering down here. So I might get someone in the fam to come and run that over in just a second, but there's no rush. Yeah, okay, all right. My lovely wife is actually just going to come and grab that print and bring it over so I can show it to you folks. But in the meantime, sort of like while we're waiting for that, in terms of the iteration time on this design, the longer that you spend designing an object, I think the more satisfaction that you're going to get out of it, right? Because you want to basically be able to try out the maximum number of things at once. So let's just say you're trying to learn curves and bevels. You maybe will make a test object that is curved and beveled, and you want to get a relationship between, how is my printer working and how is my concept of this working relative to sort of how it actually turned out. So there's that. Okay, so we're running a little bit short on time. So what I'm going to do is that I am going to switch over to the actual Tinkercad component of the class. So for those of you who have signed up for it, great. If you haven't, no worries, just follow along. There will be a recording of this presentation and you can follow along a little bit later on. But what you want to do is that you want to be able to use the Tinkercad link that I sent you and just click on that, log in using your nickname, and then, in fact, let me just go back to sort of like what you'll see. You'll probably see something like this. So you'll see a page that looks like this, which is going to have basically this front here. And then what you want to do is that you want to just go ahead and create new design. So thank you. I'm just receiving the cube. Thank you. All right. Super cool cube. We'll go into this in just a minute. But anyway, so once you're in Tinkercad, this is the workspace that you have. And when we look at the work plane here, this work plane corresponds to sort of what the bottom of the printer looks like, right? So what will happen is that your object will be built up from this when you want to be able to print it. And Tinkercad is relatively straightforward. There you go. What you can do is that you can use like a lot of 3D packages, you need to figure out basically if you're using a trackpad or if you're using a mouse, what the right button is to click to be able to tumble it around. If you're using a mouse, what you do is that you right click on it, and I believe that you use option click or control click if you're on Windows and you're using a trackpad to be able to move this around, so you can get an idea of sort of like what your workspace looks like. And then what you can do is that you can very quickly start building something up based on the library of objects that you have. So what I'm going to do here is that I'm going to start with building something constructively, right? So what I'm going to do is that you select the little box thing you have and you just drag it onto your work plane. So what this will do is that it will give you a little box, and in fact, let me just move myself out of the way because I'm in the way just here, so you can see this a little better. Okay, so we've got your little box here, and what you can, if I sent this to the printer to print, it will print just this little box. So this little cube that this is exactly what I got out of Tinkercad. I just sent it a little cube and it printed the little cube. But then you can very quickly sort of start making this shape a little bit more complicated. So if I wanted to, for example, add a hat on this, so let's just say I wanted to turn this into sort of a little pyramid. What you do is that you drag your little pyramid shape over, and what you can do then is that you can when you select an object, you have controls here for moving it around. So if you look at the base here, you've got a little thing for changing the angle. So you can select it and move it, say 90 degrees if you wanted to do sort of a 90-degree turn on it. And then if you wanted to move it up and down, you select the little arrow that goes with it, and you can basically just move it up like that. So I'm going to move it so that it is aligned with the top of the box here, and then I'm going to drag it over like so. And what I've done is that I've added a little hat to the box, and then I can do is that I can select one of these little corner controls to then change the height of it, and I have the world's worst house. What's fun about this is that it's kind of vaguely PowerPointy, right? So for those of you ever to use any sort of like Illustrator or PowerPoint, there's this concept of grouping, right? So what I can do then is that I can take this object and I can group it, and then now it is going to behave like a single object, right? So this is one object that's all together. So I can take this and I can move it around, and then if I want to ungroup it, there's this little ungroup command here. Now, this is where Tinkercad really starts to get interesting. Tinkercad is based on the principle of constructive solid geometry, which basically means that you create things by taking your primitive shapes and combining them together by adding and removing them to create different shapes. So what I'm going to do is I'm going to take this object here and I'm going to copy it. So let's see if this works. How do I copy? Dang it. I think it's a right click. This has gone out of my mind now. So we've got this shape here, and I am embarrassed to say I've forgotten what the copy command is. I think, well, okay, so the way I've done this is, I can't see it in the UI, but what I'm going to hit here is Command C, or on Windows it's going to be Control C, and I'm going to do, Control C, Control V to make a copy of it, right? So I'm going to Command C to copy, and then Command V to paste. So, sorry, it's not obvious here because it's not showing up in the UI, but what I've done is I basically use, Control C, Control V to make a copy of this object. Now what I'm going to do is I'm going to take that object and I am going to scale it. So I'm going to make it a little bit smaller, and let's make it a little bit thinner, and I'm going to make it a little bit further down like this. I'm going to take this object, and then what I'm going to do is I'm going to change its type. So when you select the object, you can say it's solid, but then what you can do is that you can change its type to whole. What does that even mean? What happens now is that you can use this whole object to literally cut a hole in another object. So I'm going to take this shape over here, I'm going to move it over here, and then what you do is that you select this, hit Shift, and select the other one, and then what you do is that you combine them together. And what's going to happen is that the hole is going to act on the solid. So now what I've done is that I've taken this and I've used it to cut a hole in this shape just here. So is that sort of like reasonably clear what I've done? Yeah, it's a little bit funky, but what you can then do is that you can combine these operations to make enormously complicated things. So Tinkercad is weirdly powerful like that. It's as far as I can tell, all of the computation for figuring out how you add and subtract stuff happens on the Autodesk/Tinkercad side. So you can actually you can take really complicated models which you import, and that's how I did the kit mashing. That's how, for example, I added beefy arms to the rabbit. I basically used, I had a model which had arms on it. I cut the arms off it using a hole to basically, so I just had the arm. And then what I did was that I took that arm and then I combined it with a bunny, just using that combine operation to generate this overall object, if that sort of makes sense. So what I'm going to do is I'm going to delete this, and I'm going to show you what I would like you to try. So I think kind of a fun and illustrative exercise here about learning what 3D printing can and can't do. What I want you to be able to do is that I want you to generate a key and a keyhole. That's really, really, really simple, right? So let's just say I've got this box here, and that's going to be my keyhole, right? So we're going to use this as our basis for a box. So what I'm going to do here very quickly is that I'm going to generate my key shape. So let's make this nice and thin. So what you do is that you grab that, and I'm going to make it, let's see, how thick is this? I'm going to make this about 6 millimeters thin, which is pretty thin, but it's about right. You probably know for 3D printing, and especially FDM printing, You don't want to get much thinner than about 1 millimeter, because that starts hitting the limits in terms of like, your print will start warping if it gets any thinner than that. So only start doing that once you're a little bit more familiar with what 3D printers can do. But what I've got is that I've got this is going to be my keyhole shape. And what I'm going to do is that I'm going to generate a key shape here. So let's just say I am going to take a cylinder here, and I'm going to shrink this down and make it sort of a funny shape, like this. Let's just make it like that, and then like this here. And then I'm going to give it an arm, which looks like this. So I'm just dragging in my little box here, and I'm shaping that down. And this is the world's worst key. It's not great, but it'll do, right? And then let's just give this a couple of teeth, right? So I'm just going to Control-C, Control-V to get another copy of that out. And let's just say put a little funky tooth here, and funky tooth here. And then I'm going to make another copy of that tooth, and let's put that over here, right? So it's a pretty terrible looking key, but it works, right? So I'm going to take that. You can actually select things individually by just selecting them and hitting Shift to start selecting more things. Or what you can do is that you can actually group them together like so. And then what you do is that you combine them. So there's my little group shape. Now this is a bit thinner than my shape over here. So what I'm going to do is we notice that if I wanted to use this as a key, that's not thick enough, but that's okay. What I'm going to do is that I'm going to make a copy of this. So Control-C, Control-V. And then I'm going to make it thicker. So I look for the little control over here, which controls the height. So generally speaking, that's the thing that lives behind that little up arrow there. And I'm just going to make it pretty tall. But then what I'm going to do is that I'm going to combine it into a hole. And I'm going to combine my hole shape and move it over to here. So then what I've got is that I can take that hole shape, combine it with the box, and then I hit group. And what's happened is that I've turned that into a key and a keyhole, right? So you can see here that this sort of fits exactly in here, and you can use that as a sort of a really, really, really basic key and keyhole. Now, I'm not going to tell you why this won't practically work as a 3D print. In terms of will these pieces actually fit together? Can I slide this key into the keyhole? I'll tell you that it won't work, but I'm not going to tell you why until next week. But what I want you to do is I want you to have a guess as to sort of like what the problem is. And I'd like you to sort of like, if you're up for it, please go ahead and try making one of these. So let's just say, I don't want to be dreadful and set homework, but let's just say you give this a little bit of a go. And if you're using the Tinkercad class login using the nickname, I'll be able to see the designs you make, so I can sort of like I'll know when you made it, and I can have a review of it, and I can actually tell you sort of like how it's gone, and maybe actually print it so we can actually talk about it next week. Otherwise, if you're using a Tinkercad account on your own, let me know, just email me, and we can go over how you can share the design with me. And what we'll do is, let's just say we get this done by next Wednesday. So that'll give me some time to actually print out a couple of the designs, and we can talk about sort of like, okay, so we've got this concept in our head of having a key that fits in a keyhole. When we actually tried to print it, how does that actually work out? Why does it, what pieces around this have worked, what pieces around it haven't worked? So does that sort of make sense for everyone? Cool? Mostly? Yeah, we're all good? Awesome. Cool. All right, so I am going to back over to the overhead camera, and I'm going to show you the little cube that we printed out, right? So this was the little print job that I kicked off earlier on. Right at sort of about a third of the way into the class. So you can see what it's done is that it's printed this tiny, tiny, tiny little cube. I'll go into it a little bit more next week, but you can see at the bottom what it's done is it's printed out this thing called a raft. And what the raft does is that it prevents the print completely sticking to the actual print bed. And what you can do is that you can take the raft off to complete the design. So I'm going to try taking it off here. So it sort of like just snaps off here. And then you can see that we've got this, completely dimensionally accurate, not completely, fairly dimensionally accurate 25 millimeter cube. That's a result of the print. All right, awesome. Again, thank you so much for coming along to this. This is a first for me. I've never tried sort of like doing quite so much of a production in terms of teaching a class, so I appreciate all of your patience. And we'll chat a little bit more next week. All right, thanks all. Bye. Bye.